Okay, this video is about finding domains by just looking at the function equations. And we don't want to overcomplicate this. There's only a few cases, like two, where we have to worry about domains not being negative infinity to infinity or all real numbers. So when I look at this first case, is there any number I can put in for x where I get division by 0 or square root of a negative number? Because those are the two things we have to worry about. Well, I don't see any square roots, and I do not see any division, so I can pick any real number I want. And that means I could write it a couple different ways. I could use a big R, I could write out in words all real numbers, I could write out set builder notation. This is interval notation, negative infinity to infinity. There's a multitude of ways of writing it. Next one down, x squared minus 3x is g of x. Again, I do not see any division. I do not see any radicals, square roots. So my domain, again, is all real numbers. But on the next one, I do see a division. I have 4 divided by x minus 6. Now, we've done enough of these, I think, by now. What can I not put in for 6? Well, I can't put in 6, because if I did enter a 6 in for x, I would have 4 divided by 6 minus 6, or 4 divided by 0, and that's undefined. It does not exist. So my domain would be written as x is not 6, or x, or all real numbers except 6. All real numbers except 6 written out in words. I could write out x is not equal to 6. Here's set or interval notation. Negative infinity to 6, union 6 to infinity. This is a little awkward, but you're going to see it. So again, when you see division, your radar should go up that, ooh, there's probably something happening with my domain. And the way you find it is, you take the denominator, set it equal to 0, and see what value gives you 0. Here's a more complicated one. I have division. I have 3x plus 11. If I take my denominator, which is 3x plus 11, and set it equal to 0, and solve it, I get x is equal to a negative 11 thirds. So if I were to place a negative 11 thirds in for x, I would get division by 0. So my domain is all real numbers except negative 11 thirds, or I could write it in interval notation this way. Notice on both these are parentheses and not brackets because it can't take on the value of 6 or the value of negative 11 thirds. Radicals, a little bit different. I cannot have negative numbers under the radical. So generally what you're going to do is take whatever's under the radical, like right here, and set it greater than or equal to 0. And if there's any solving to do, you solve, or you're done. In this case, you're done. My domains, all numbers greater than or equal to 0. I could say all positive numbers, including 0. I could write like this in interval notation. Example 6 is a little more complicated again, but again, I have a square root. The value under that cannot be equal to, or greater, or excuse me, cannot be negative. So I'm going to set that greater than or equal to 0. And I'm going to solve that inequality. Divide or subtract 2, divide by 4. I get x is greater than negative half. So my domain is from negative half to infinity. So we don't want to overcomplicate this. If you do not see divisions or radicals, your domain is probably all real numbers. If you see divisions, well, your domain is probably going to be everything except one value. There's exceptions, but for right now, this will work for us. And if you see radicals, you're probably going to end up with inequalities saying what your domain is.